The main topic of today will be consuming Web API. So if you want to write the consumer that accesses a Web API from C#, for instance, from a mobile app, from a WPF app, from a console app, things like that. That is what we are going to talk about. And we are going to talk about consuming Web APIs in ASP.NET Core 3. And you will see a lot has changed. If you have accessed Web APIs before, then you will probably learn something new today. But before we go into this topic, I would like to recap something where I saw in today's exercise that not all of you are perfectly familiar with. And that's the Visual Studio Debugger. I would like to show you some basics and also some more advanced tips that are not as obvious. So let me quickly start a new instance of Visual Studio, create a new project, just a console app. You can follow along, but you don't absolutely need to. So I will just describe some tooling, okay? So let's create a console app. Good. I don't have internet. Why don't I have internet? Let me quickly disconnect from the network and connect again. Maybe this helps. Come on, come on, come on. It will work. Currently, we don't need internet. So let's write only a few lines of code. Maybe create a local variable, var my value equals to 42, and then let's change this my value, maybe by adding one line. Then let's print something, the my value, for instance. Then let's do a static void do something. Very simple function, again, console write line something. And let's call this guy do something. That's all. Now maybe I'm not perfectly sure whether my super complicated algorithm works. What I typically do, I set a breakpoint. You see, a breakpoint can be set either by putting the cursor in a certain line, pressing F9, or by clicking here in the gray area on the left-hand side. This sets a breakpoint. First important tip, maybe you're not aware of that, you can right-click on such a breakpoint, and then you can specify a condition. You can, for instance, say, no, I don't want to break all the times when I'm entering here, but I only want to break if a certain variable has a certain value. For instance, you are looping through, and if you reach the iteration 1000, then you want to break. This could be done here. So we could, for instance, say we only want to break if my value equals 43. In our case, that's the case because we start with 42 and we add 1, so it will hit the breakpoint. But if I would say equals 40, it will ignore the breakpoint. So conditional breakpoints are sometimes very handy. Okay? How can I start the debugger? Starting the debugger is really trivial. Just pressing the green play button up there and it will start the debugger, and the debugger will stop wherever you have a breakpoint. So in my case, the debugger stops exactly here. See? Now if I want to inspect the values, that's really trivial. I can hover over such a value, then I see it here. I can hover over any occurrences of this value. And what I can do then, and that's something which is very, very nice, I can pin this value in the debugger window. You see it? So if I want to keep the variable always in my focus, I can pin it here, and that will also travel with my code. So if I scroll, then you see that my debug, my watch expression will scroll with my code. But that doesn't need to be like that. I can unpin it from the source. Still, my value is here, but now it somehow floats over my code. You see that one? So if I'm jumping through my different functions and so on, the value will always be in my focus, and I can take a look why my application doesn't change the value as I would expect it to. You get the idea? So this is a very nice feature. If you want to go further in your application, you can easily do that. You just use these buttons up here or the function keys F10 and F11. What is the big difference? If you press F10, step over, and we are here calling the doSomething method, if I press F10, it will just execute doSomething, but it will not debug into the method doSomething. Another important trick, I don't know if you knew that, you can take this yellow line here, this yellow arrow, and you can just move it up to re-execute code. So you can change the instruction pointer on the fly. That's a really nice thing. So I can now demonstrate you the difference. F10 jumped over the doSomething method. If I press F11, I'm jumping into the doSomething method. Saw it? Now the debugger goes into the method and I can debug the doSomething method. At a certain point, the doSomething method is done and I will be back in the main method, everything's fine. Another nice thing, if you are taking a look at the performance of your app, is this one. Visual Studio will always give you an indicator how long the last statement took. So if you have a method which does a lot of file and database I/O and things like that, and you wonder how long did it take, then you can read it here. You don't need a stopwatch and manually take a look at the watch. Oh, did my performance optimization really work? Did it make a difference? Well, you can read it here in Visual Studio. That's really nice, I think. Okay, good. Let's stop the debugger and try something else. Let's add a third method, static void doSomething else. And let's again do a console write line, something else. Good. And let's create a helper variable var foo equals bar. Good. Restart the debugger. Good. Step into doSomething. Sorry. I forgot to call doSomething else. I'm sorry. My bad. Let's quickly set a breakpoint here. Let's remove this breakpoint here and run it. Good. Now we are here. Step into. What I now would like to show you is this guy down here. You have the so-called call stack. The call stack shows you here in a graphical way where you came from. You started in the main method, you entered the doSomething method, and from there you entered the doSomething else method. Okay? But this call stack is very useful because imagine you are here in the doSomething else and you want to see, okay, what is the status here in the doSomething? You double click it and you can walk up the call stack and you can inspect the variable foo although you are currently standing in the doSomething else method. Get the idea? So you can take a look in the call stack a little bit above. You can even go into the main method here and you can take a look at the my value. And that is sometimes very, very useful if you want to find a bug in your code. Good? Good. So this is the call stack. The call stack works more or less good if you have async methods. You don't need to follow along. I just want to show you something. Async task, something like this. Give me a using, yes, and make this an async task. And to make it async, I'm cheating now a little bit. It's not absolutely necessary that you fully understand what I do now. I say await task dot delay 100 milliseconds. I'm just waiting, I'm wasting time 100 milliseconds. That's all I do. And then again I say await and async task. So now I have an async program. That would be typical for a web API. I told you when we develop web APIs, it's really important to always use async APIs. And here I'm using async APIs. And the thing I would like to show you is if I go here and set a breakpoint and I press F5 or run the program, the debugger will stop. It will stop, but not at the right thing because I forgot one await. Let's try it again. Good. And then take a look at the call stack. Don't worry about things like that. Just ignore them. Visual Studio, if you take a closer look at how async await works, then you will see that async await generates a bunch of code. So just by using await, you are implicitly generating a lot of C# code behind the scenes. You don't have to care about this code because Visual Studio and the C# compiler will generate it automatically and it will just work. But in the call stack, you see a little bit of this async code glimpsing through. And this is what you see here. So when you are debugging, just ignore these things. They are just here because you are doing async programming. In many cases, Visual Studio will just work. You are lucky because you are pretty young. If we would have sit together 5 years ago, then the call stack would be a mess in Visual Studio when you use async await. But nowadays, Visual Studio is really smart, detecting or analyzing call stacks with async methods. So to make a long story short, call stack just works, even in async programming. Yeah. It might be obvious for you, but it isn't. Okay, so this was the call stack. What else can I show you? Yep, let me set the breakpoint here and run it again. Now here I have a scalar value, my value here. Please note that you can always click on the value and you can change this value on the fly during debugging. Saw that one? So this is something that many people don't know. They stop debugging and added some code to change the value. That's absolutely not necessary. It just works. Even with string variables. So if I set the breakpoint here and let it run, continue, and I can go to foo, you see that one? I can click here and I can change it even with strings. It just works. Good? Good. If you have a longer string, like a JSON stuff, you also have so-called visualizers. You see that one? It's just a larger visualization, and if you have a very large string, then it is somehow handy to click on this magnifying glass, and then you see the value in a larger dialog. But changing the values on the fly is really very useful. This also works if we create a little bit more complex objects. Let's say we create people, and those people are an array of objects. So let's create objects. My example that I always do is foo, and maybe last name equals bar. Good. Let's create multiple persons, multiple people. Something like this, and unfortunately, new var. Unfortunately, all people have the same first name. Okay, could happen, and they also have the same last name. Okay. Now let's select a person. Var person equals to people. Let's select the first one, or let it even make more interesting by using the random number generator. One of the 4 people is chosen randomly. Good. Run the debugger. If we hover over person, then you will see the first name and the last name. We can use this icon here to extend it. Then we see the simple property values, and we can even change them. See them? I can click in it here. No, I cannot click in it here. Now I can. Okay, I cannot click in it here. Okay, is like it is. But the problem is, if I take a look at this person, foo bar, if I take a look at people, you see, list, foo bar, which one has been selected? See the problem? We don't know which one. Is it the first one or the fourth one or the second one? I have no idea. There is another feature in the debugger which is very, very useful. Imagine that you have a list of Pokemons, for instance, coming back from the web API. And then deep down in your call stack, you have one Pokemon in your hand. And you don't know, is this the first one or the 7th one that I got back? You somehow have to track this Pokemon around your whole application. In this case, you can hover over person, right-click on person, and choose here, make object ID. If I click on, let's do it again, make object ID, and I hover over it again, then you will see that it now has a $1 here at the back. And if I hover over the people now, then you will see that we immediately can identify the person. It's the person with index 2. Because again, we see the $1 here. Do you get the idea? I can also mark that one and say this is an object ID, and now this person has the object ID too, and so on and so on. Understand the principle? Make object ID. That's very useful when dealing with applications, when dealing with data structures that are a little bit more complex. Next one. This was, I think, your question from the beginning of the lesson. You asked, how can I pass in those arguments, these command line arguments? You can right-click on the project, go to Properties, and then you find, here in the debug area, here, the possibility to add arguments. So what I can do is I can say arg1 and arg2 and hello and world. Let's save this guy, go into Programs, breakpoint is already set, and run it. And now if I hover over args, then you will see that you have all these arguments here. So no need for readline, just use these arguments and right-click Properties, and that's it. An important information, I got asked this question in the other class, is it also possible to pass in these arguments without the debugger? Yes, it is. If you specify arguments here, they are always passed to the program. It doesn't matter whether you say here, start debugging or start without debugging. You will always get these parameters. Okay, so if you press Control plus F5, then your application will run without the debugger and it will still get the parameters. Good? Good. All these things work because you are here in the debug version application. You see that one? This is the default in Visual Studio, so everything is fine if you keep your configuration as it is. If you switch to release, you could do that. Release, and then you start to run the debugger. It doesn't make very much sense because you get a warning message. You are debugging a release version of console app 2. And that doesn't work. Well, it does work with a little bit of tricks and it is very inconvenient. But to make a long story short, don't debug with release mode, debug with debug mode. Release mode should be the mode that you use when you compile the program for shipping it to your end customers. Because the release mode is really the fast version of your program. Never ship a debug version of your code. Many customers called me and I had a long trip to visit them and they asked me to take a look at their application, why it's so slow, and the only thing that I did is I went to Visual Studio, I switched from debug to release and the application was 25% faster. And I could travel home again. No, of course we did other things. But this is really important. Never ship debug versions because they are horribly slow. They are very convenient for debugging, for finding mistakes, but they are not fast. Next rule, never do performance optimizations in debugging mode. If you optimize your application for performance and you do that in debug mode, then your results don't have any value because you will not ship the debug version. You will ship the release version. And maybe you are hunting a performance problem in debug mode that doesn't exist in release mode. So if you do performance analysis of your application, then always do it with the release version, never with the debug version. Get the idea? Good. So, the basics that you should absolutely remember are breakpoints, starting your app, F10, step over, F11, step into, that's it. You have learned how to manipulate variables, you have learned how to set object IDs, I've shown you how to work with the call stack, and I think this should be the basics that should equip you with enough information to survive next week's exam. Any questions regarding the debugger? This works with ASP.NET Core applications too. So just if you have a web API, just set a breakpoint and that's it. Good. With that, let's stop the debugger stuff and let's start with the consuming web APIs. Let's go away with that one and open the slides for now. We are here in this one. Good. It's the next chapter here. Maybe you have already consumed a web API before, and the class that you probably used in C# is HTTP client. Very similar to Angular. In Angular we also have the HTTP client module and we use the HTTP client. However, unfortunately the HTTP client of ASP.NET Core is very often used wrong. And I want to tell you how you use the HTTP client correctly. I added a link for you to the HTTP client class, and many people take a look at the documentation, they open it here and they see an example and they see, I new up an HTTP client and I can call get async and I'm fine, I can go with that. But a very important thing is important to understand. HTTP client should not be created for every situation where you need to call a web API. You should create a single HTTP client and use it over and over and over again. So if you take a closer look at the example in Microsoft's documentation, then you will see that the HTTP client is a static read-only variable. And you should use the same variable over and over and over again. It is built for that. To be more specific, per host, for instance, if you access the Pokemon API and if you access the GitHub API in your own application, you should create exactly two HTTP clients. Okay? For each host, one client. If you don't do that, if you create many instances of HTTP client, at one point in time, your application will run out of TCP sockets. And this is somehow annoying because then you get very strange error requests from your customers, support requests from your customers, and you don't know why. Everything works fine on your computer, but on their server everything crashes. Okay? So it's important to do that. The next thing that many people do wrong when switching from ASP.NET Core 2 to ASP.NET Core 3 is that they continue to use something that is called JSON.NET. I guess you have used JSON.NET before, Newtonsoft JSON, right? At least some of you? Okay, you don't need any longer. Because in ASP.NET Core 3, .NET got its own very fast implementation of a JSON parser and serializer. It's much faster than JSON.NET by a factor of 2 or 3. It uses less memory and therefore it's the preferred way of handling JSON in ASP.NET Core 3. So stop using JSON.NET and use the new .NET Core version. Granted, JSON.NET has more features than the JSON support in ASP.NET Core 3, but still it is the better option for 9 out of 10 cases. And don't worry for James Newton King, the creator of JSON.NET. He still has a job. He is now with Microsoft. I don't know if he is an employee or just a freelancer, but he is part of the team creating the new JSON serializer. So they didn't create, let's say, a competitor for a successful open source project. On the contrary, they invited the creator of this open source project into their own development teams, and now they work together. Good? It's still open source, but it's Microsoft maintained open source. Good. Let's start with this one and we will get back to the next pieces here in a few minutes. So how do you do that in practice? Well, calling a web API is really not difficult. What you do, the first thing that you do is you create so-called data transfer objects. Can you remember the Pokey API that we have used previously? The Pokey API gives you a list of Pokemons and per Pokemon a property named name and some other properties. And this is what you have to do. You create one class per data transfer object, and now comes the important part. Don't forget the JSON property name here. In the past, if you have used HTTP client before, then you didn't have to do that. Because JSON.NET, what it did is it took a look at the first letter of the property if it was an uppercase letter in C#, the uppercase letter was automatically translated to the lowercase letter in JSON. This is no longer the case. So if it doesn't work, if your code doesn't work, remember to add the JSON property name property, attribute, sorry. Get it? Just remember that. Next one. If you now want to really access the HTTP client, you have to do 4 simple steps. First, create an HTTP client. Typically, you define a base address for the HTTP client. In my case, it's Pokey API CO API v2. The advantage of the base address is that if you specify the base address, you don't need to specify the base address over and over again. So this here, this URL is now relative to the base URL. You get the idea? So that's important. The base address is optional, but it's very useful and you should definitely do it. So the first thing is creating an HTTP client. The next thing is calling getAsync. Always use the async method and use await and async and so on. Then you can use the helper method endure status code, and this will throw an exception if the server returned a status code which indicates not success but error. Maybe an internal server error, maybe forbidden, maybe not found. With endure status code you get an exception in those cases. If you want to read the content, just say read as string async. And last but not least, you call the deserializer to get the Pokemons from the string. Sounds medium complex, so let's take a look. This is not the right one. This is the right one. What? Oh, I've moved the solution. Sorry, I have to open it from here. Open a project or solution, and it is here in my GitHub and here and ASP.NET Core and Consume Web API. Here it is. Good. This is exactly the code that you have seen before. So let's quickly step through it. If you want to follow along, it's in my GitHub repository. Let's close that one and let's close that one. I'm back on the internet, that's good. Here in ASP.NET Core, here in Consume Web API. This is the example, okay? But you can also take a look at the video. Let's run this app. In the debugger, of course. Now we stop here in the debugger, and the first thing, if we take a look at the HTTP client, we will see that it has set its base address. So, to recap, this one is relative to this one. Simple thing. Let's get over it. Good, it does the HTTP request. Internet is not very fast currently, so we see that it takes a while to read the Pokemons. Come on. Yeah, sometimes it's fast and sometimes not. So we got it back. Let's take a look at the response. Yoo-hoo, status code 200, okay. So we will probably survive the call to ensure success status code. Let's step over that one. Yes, it worked. Now the next one is the read as string async. So we get the HTTP body. Let's read the HTTP body. And if we take a look, this is the JSON content as string. So we can use the visualizer here. And you see, we get back, here it is, a JSON object. And here we see the results. And here we get an array of Pokemons. This is what we want to deserialize. This is just string. And now we have to turn this string into an object. And this is done using the JSON serializer. This is not JSON.NET. This is the built-in version of the JSON serializer in .NET Core 3. That's brand new. So let's call this guy. Good. And now you see we got, Pokemons. We only got the name, but we didn't ask for more. And then we just print all the names on the screen. Let's do that and let's take a look. Yes, it worked. We have printed all the names of the Pokemons on the screen. Got it? Difficult? No, isn't it? Yeah. Good. So let's stop the debugger. It's getting slightly more difficult, but only very slightly, if you want to post or put or patch something. So if you want to write data. If you want to write data, let me scroll a little bit to see that one and go down. You use, of course, the same HTTP client, but this time you use post async. You use the URL. This is again relative to the base URL that we've set before. And then we have to somehow come up with an HTTP content. How do we get the content? Typically, you use the string content helper class, and there you use the JSON serializer.serialize to turn objects into string, right? It's the inverse operation. Before we turn the string into an object, now we turn an object into a string. And then you have to specify two additional things. Don't worry, you can copy it from my slides during the exam, during homeworks, or finally your projects. These are the two settings. You have to specify that you want to use UTF-8 encoding, and you have to specify that it is JSON. And that's it. That's it. Just await the result. Here it is. Make sure that the status code is successful, and everything's fine. Good? Delete works equally. Post, put, patch, all work the same. Good? Nice. I don't have an example with post. We can do another example later on. Questions so far? This is very simple. For your homework, you will need exactly that. So I have a small homework. It's not a lot, and you will probably be able to start even in this lesson because we don't need for the theory the whole 2 hours. So yeah, these are the two important things that you need. Now, check. Good. Yeah, good in time. Next one. Currently, we have thought about situations where we have a client, then we have a server, and here is an API, and the client wants to access an API, and here we just created a command line executable. This is what we just talked about. So now think of a more complex scenario, and this scenario is very, very relevant for in practice. And this scenario looks like that. You have a client, something like this, or maybe you have a phone. So let's do something like this. And then you have a server. This is the API that you are currently offering and implementing. And then you have another API in the background. Maybe this is from Microsoft, from Google, from Facebook, or maybe a colleague of yours. And they are also offering an API. The client calls your API, and your API wants to call a so-called backend or downstream API. Okay? So now we are talking about this part of the solution. If we want to use ASP.NET Core, we are now a client, but not a client, but a client running on a server. Get it? It sounds complicated, but it isn't. What do we do if we are in ASP.NET Core and we want to access a downstream web API? In this case, we should not manually create the HTTP client. We should not do that. Instead, and that's pretty new, we should use a service which is called HTTP Client Factory. This is a link to a Microsoft documentation page where you can read all the different features that this HTTP Client Factory supports. And we will only talk about the basic usage and the named client usage. The more complicated things with typed clients and generated clients, we will only scratch the surface. But this is pretty powerful, and if you want to learn more about it, read the whole documentation article. But it is not relevant for your exam, just if you're interested. Or maybe you will need it in your practical work, we'll see. So let's give it a try. I want to show you how HTTP Client Factory works. So If you want to follow along, you are invited to do so. Please create a new application in Visual Studio Code, not in Visual Studio, and create an API application. ASP.NET Core Web Application. Select that one, Web Application, Core, and put it somewhere on your disk. So I will call it, I don't know, calling backend sample, but you can call it however you want. As the template, please select ASP.NET Core 3, select API, and hit create. By the way, because somebody asked me, I can't really remember if it was somebody in this class or not. If the somebody was in this class, I'm sorry. Next week, you will definitely not need to write an ASP.NET application or something like this. Next week is C# exam, so just the console app. Okay? So the things that we discuss now are relevant for the week after, when we have the mobile computing exam. Okay? Good. So now we have a simple backend. If you take a look at what this backend can do out of the box, it's really, really trivial. It only has a single controller. It's called weather forecast, and it will simply return very simple data about fictitious dates and temperatures and so on. Okay? Very trivial what it does. So in our case, we want to implement something different. In our case, we say we want to have, as I had it before, the client. This is the API that we focus on, and we are going to call the Pokey API as our backend API. So we will focus on this step. This is what we are going to do. Good. Now let's do that. Let's first clean up a little bit, okay? So let's rename the controller to Pokemon controller. Let's get rid of the demo implementation. We don't need a logger today. We discussed loggers before. And let's get rid of all this code. So your application, your code should look like that. Ah yeah, and by the way, you can also delete if you want this weather forecast CS. We don't need it. This is how your code should look like for the upcoming sample. Have it? Nice. Now if we quickly refresh our minds, the Pokey API, this one, returns a list of Pokemons looking like that. We get a top level object containing the total counts of Pokemons, a little bit of next and previous. We are going to ignore this stuff. And then we get a results element, which is an array, and in this array, for each Pokemon, we get a name and a URL. This is what we get back. So what we need to do is we have to turn this JSON into C# objects because we want to access it from C#. And for that, we create so-called data transfer objects. And I did that for you. Please go to my slides, and in the area consuming web APIs, on slide 6.2, you find these two data access objects. For this example, you can just copy out this code. Copy it. And put it maybe in a separate file. I will call this file data transfer objects. Good. DTOs. Many people talk about so-called DTOs. Add a using, and good. I don't think that we have a break. I know it has been a long day. We will finish this example, and afterwards, the rest of the lesson, you have time to already start working on your homework, and if you want to grab something to drink, please wait for another few minutes until we finish the theory lesson, And when we start in the exercise part, feel free to get a coffee or something to drink. But I would like to now focus on this example and finish it, and then you can take a short break if you want. So these are called, again, data transfer objects, because they are used for transferring the JSON data from the backend web API into C#. You also often hear the terms POCO. Have you ever heard that? C# POCOs. You hear that very often. Plain old CLR objects, yes, exactly. Plain old CLR objects means nothing special, just classes, no framework, nothing special. POCO data transfer objects. But remember, JSON property name, because, just to recap, this is the problem. Uppercase N is the name in C#, lowercase n is the name in JSON. Have you ever heard the term idiomatic code? Who is not familiar with this term, idiomatic code? You hear that very, very often. If you are in practice and somebody tells you, you are not writing idiomatic code, then this guy means that you are writing code which does not adhere to usual coding standards in the language. So for instance, in C#, it's usual that class names start with an uppercase letter. So if you do something like this because you come from Java and you use a lowercase class name here, I think Java uses but lowercase function names, right? Okay, so if you create a lowercase function name, then somebody could come to you and say you are not writing idiomatic C#, and he means that you are not writing code which follows the typical guidelines for C# coding. So this is the term, idiomatic code. You hear that very often. Good. Now we have data transfer objects. We can go into our Pokemon controller, and now we need an HTTP client. And what we shouldn't do, and that is a deadly sin, something like this. HTTP client equals to new HTTP client, something like this. This is not okay. Why isn't it okay? Because for every GET request that we get, we create a new HTTP client. And if we get a lot of HTTP requests on our server will run out of TCP sockets. And then we can reboot our application or even the entire server to get it up and running again. And that will definitely happen at 3 o'clock in the morning on Sunday, where you definitely want to sleep. And then you get woken up, and that is not funny for nobody. So therefore, this is not okay. What we do instead is we follow the guidelines in the Microsoft documentation. We already open it. And you see in the basic usage area here, the first step that we need to do in the startup class configure services, we have to add this one line. Services.add HTTP client. So let's go to startup. Let's go to configure services, and we just say services.add HTTP client. This will provide HTTP clients to all our controllers. If we do that, the next thing that we can do is we can go into our Pokemon controller and can use dependency injection. After the last homework and after the lesson last week, you should already know what dependency injection is. Now we can say HTTP client factory. This will give us a factory with which we can then create instances. Have you ever heard of the factory pattern? Is this something new, or do you know what I mean? Let me see. Factory pattern, this one. See, there is a Wikipedia article about the factory pattern. Ever heard of that? Yeah? No? Okay, the factory pattern, do we have a picture here? Yes, the factory pattern is like this. Normally, you create an object by just saying new object name, class name, right? With a factory pattern, you have a separate class or method that you can use to create the object. And maybe this class will take some cached values or something like this. So factory gives you more control about creating the objects. It's just a pattern for us. Well, yeah, it's called a factory. If we have the factory, we can use this factory factory to create a client. And then we simply store this client. So we say client equals to. Now take a look at my Visual Studio. I have a tip for you. Now Visual Studio tells me, hey Rainer, client, I don't know what you mean. I don't have a variable, I don't have a property. What is client? Now you can use this light bulb here and let Visual Studio generate the code for you. You can just say generate read-only field. Now take a look what's going to happen. Click on it and it automatically created this line of code for me, and now everything is okay. So sometimes it's really useful if you know, okay, I have to add a variable, just write it here, press Ctrl dot, that's the keyboard shortcut, select the read-only field and you're done. So that's really, really boosting your development productivity if you know a few of these shortcuts. Yeah, everything's working good. Now we have a client and now we can use it. Let's maybe just return an enumerable of string. We will just return Pokemon names. And let's implement it. Let's quickly recap what we did. First one was client dot get async. We need to pass in the request URI. What is the request URI? Let's quickly go into the slides here. Where is it? Here. In our case, the request URI, here, was relative to the base address. Did we specify the base address somewhere? Nope, not yet. Exactly. This is why currently, and we will fix that in a second, this is why currently we have to specify the whole address here. We don't have a base address yet, but we will fix that. Now what do I have to do in order to work with the async method? Let's recap that. Wait. What else? Async. Perfect. These are the 3 steps. Use await, put async in front of the method, and return a task. That's all. Now this is the response. Next step is we have to check whether the response indicates a success. Response.ensure status code, success status code. This will throw an exception if something went wrong. Next, we have to read the HTTP body. Response.content.read as string async. And of course, because it's async, await. This will give us the Pokemon JSON string. Just a string, not objects yet. Now we have to turn this string into objects. Var Pokemon equals to, not using Newtonsoft JSON, not JSON.NET, but we are using the faster and more memory efficient version of the JSON serializer, which is called JSON serializer. It lives in the namespace system.text.json. Deserialize Pokemon. And of course the Pokemon JSON string. Good. Got it? Now we have the Pokemons. It will throw an exception if it can't resolve some names or things like that. And now, let's return the Pokemon names. So let's say Pokemon dot results dot select p goes to p.name. And return it. Looks good. Any questions? Or is that clear? Yep. Cool. Now let's give that a try. I have heard one question over and over in the other class, and so I'm going to tell you that here too, because maybe this is a question here too. If I call this application now, click on it, calling backend sample, then it's very annoying that whenever I run it and the browser comes up, that the browser is always in the wrong URL. I always have to say Pokemon in order to get something. But before I continue, hooray, we get the correct result. So we now called from the client, this is our client, we called our server, this is our server, and our server called to the Poke API. Poke API. Okay, so we have exactly now what I've drawn on the screen. But how can we make this one work? This works like that. If you go in Visual Studio, right-click on the project properties, go to debug.
I think you have mentioned it earlier.
I have mentioned it earlier, so I just repeat it. Pokemon. Got it? The reason why somebody in the other class struggled was they unintentionally selected IIS Express, changed the value here, but they didn't change it here to IIS Express. So they just forgot to switch the profile to the profile they used. So this was the reason why they were struggling. Now it should work. Let's see. You. Good? Good. So, I would like to show you something else. This is done out of the box. If you are using the iHTTP client factory, if you use the factory, you see that the HTTP client is automatically wired up to your logging framework. So remember what we did last week with logging. Remember the sec stuff and the log file and these things. If you use the iHTTP client factory, every outgoing HTTP call will be logged in your log file. And this is very useful. If you are hunting a bug, a user call you that something doesn't work, then you can take a look in the log file and you will see all outgoing requests, and you will also see whether you received an OK message, OK status code or not. Here you see the OK status code. So very useful that it is automatically wired up to your logging framework. Good? Good. Nice. How can we specify this base address here? Well, we cannot specify a base address directly here because maybe we want to access 3 different servers. If we specify just one base address here, and we want to access 2 different servers, then this is not possible anymore because I only have one base address. This is the reason why you can create so-called named clients. Let me show you how this works. I can specify a name here, Pokemon or Poke API, like this. And then I can specify a callback client goes to. And now I can configure the client with the name Poke API. So I can say client.base address equals to new URI, this one. Just believe me for a second. You specify the name with the base address. Once you specify that, I will go back to this code immediately so you can copy it into your application. But once you have specified the name here, now whenever you create the client, you specify the same name. And then you get a client for this specific server. And if you want to access 3 different servers, then you have to add 3 different factories. You give it 3 different names, essentially. Get the idea? Good. So, again, here is the code. These are so-called named HTTP clients. There are more advanced scenarios where you can create so-called typed clients. You can also specify so-called policies. There is a pretty well-known framework. I don't know if I have mentioned it before. It's called Poly. It's also very nice because it has a nice logo like all the APIs, like all the open source projects. This is Poly. HTTP Client Factory works really well with the Poly project. What the Poly project essentially is that you can specify so-called policies. And a policy could be if the API is not reachable because the server is not available or because I'm offline, then you can specify you want to retry. Try it after 5 seconds again, then try it after 10 seconds, then try it after 15 seconds, and only if it doesn't work for 3 times, then I want to have an error. And this is something that you can very easily do with Poly. So if you need something like that, Google for the Poly project, because this will save you a lot of work. We will not cover that here. It is not part of the exam, but I just wanted to mention it because in practice, this is really important. We also use it in our own software products over and over again. Good. Now we have the base address, so let's give it a try whether it still works. Oh no, it cannot work. I'm sorry. Stop it. I now specified a base address, so I have to remove this one. Doesn't make sense to have it in 2 places. Let's give it a try again. Let's see whether it works. I'm positive, yeah, good, still works. Named clients. Good? Good. Now just for demo purposes, please do me a favor and add just 3 lines of code to our controller. Just to show you something, add a HTTP post. It will not do anything, just for demo purposes. It will be public void add from body, no, not void, I'm sorry, I action result. From body Pokemon P. Here we would add the Pokemon. Return, okay. It's a null operation, so it does nothing. Just to make sure that it is there. Good? Good. Now, imagine, use your imagination, you created this great API for your final year project. You do that for a customer. And what do you have to do at the end of your project? You have to write documentation. Everybody loves documentation, right? How could you do this documentation? You could open Word and just describe it, but that's not funny. A better way would be to write the so-called Swagger file. Can you remember Swagger files? You have gotten multiple Swagger files last year in the Node.js part, and you got already a Swagger file this year. Let me quickly refresh your mind. This is a Swagger file. See that one? Can you remember that? You can remember that one, right? If I select the whole file, this one, this is how it looked like. I told you that you can go to editor.swagger.io, just pass in this file, and then you will get a nice little documentation and you see it graphically. Wouldn't it be nice if we could get exactly such a UI from our API too? Well, we could sit down and write this file, this specification on the left-hand side, so we could document it. But that's somehow boring. Somebody must be able to generate that from our C# code. And that's possible, and this is what I want to show you. So the topic now is to be able to generate Swagger files and Swagger UIs to auto-document our API. And this is also the reason why it's called Swagger. If you take a look in the dictionary and look up what Swagger, I'm not sure if Swagger is really a word. Yes, it is. Angeben, stolzieren, prahlen. This is what Swagger means. So what we say here is the web server, the one that is offering the API, says, hey, you know, this is what I can do. Look at me. This is why we create a Swagger file and why it's called Swagger, okay? And we want to do exactly that. Hey, take a look what we can do. And we can do that pretty simple in our .NET, ASP.NET application. The solution for it is a package which is called nswag. There is a second implementation which is called Swashbuckle. It's a little bit older, but it's also very good. I will show you nswag because it's a tiny little bit better if you ask me, but both are open source projects, both are very, very good, and feel free to select any one of that. I prefer nswag currently, but that's just a question of personal preferences. So we can take a look at nswag, we'll go directly to GitHub. So let's add nswag, and if you want to add nswag, I've added a small checklist here to the slides. The first thing that you have to do is you have to add nswag.ASP.NET Core. Let's do that. Let's go into the Visual Studio solution, right-click, manage NuGet packages, browse, and add nswag.ASP.NET Core. And install it. While this is installing, let me give you one or two tips. What do you have to know for your mobile computing exam in 2 weeks? You have to be able to use HTTP client in a console app. You have to be able to use HTTP client in an ASP.NET app, exactly those steps with the iHTTP client factory, just the basic usage, nothing complicated. Will you have to be able to use nswag in 2 weeks in the exam? No, not yet. But this will definitely be relevant for your final exam, for your Matura. So we will practice that in the upcoming weeks over and over again to make sure that you are able to add nswag or swashbuckle to your ASP.NET app. Because some of you, maybe a lot of you, will choose to create a backend in ASP.NET Core during the Matura, and this will be one part of it because in a few minutes I will show you that you can easily generate a client, for instance for Kotlin or Java or whatever, with one click of a mouse, and then you can maybe use this in a Java UI. Just an idea. So not relevant for the exam in 2 weeks, but relevant for your Matura. Good. I added the NuGet package, and then if we follow the guide for installing this stuff, we only have to add a few lines of code. We have to add this code to the startup class, and the first thing that we have to add is this one. Again, I followed this link here. See? Guide for installing and so on. This one, copy, startup, paste. Step 1, check. Down here, we need the first 2 lines. We will not talk about redoc here. It's just a different UI for the documentation. It's not relevant. We are using the Swagger UI. Go to configure and add these 2 statements. That's all. And we are done. We're finished. For the basic usage, everything will work, hopefully. So let's check it. Let's run our app. Let's see. Visual Studio starts. We still have our Pokemons. How do we get the Swagger UI? Just instead of Pokemon, say Swagger. Bang, we get a nice little UI, and you see you can open it and you see, oh, I can get a list of Pokemons. What will I get back? Oh, an array of string, got that. How can I add a Pokemon? Oh, there is a post. And what do I have to post through the body? Oh, I have to post in a name. You get the idea? And you can even try it live here in the browser. You can click on try it out, hit execute, and it will execute the call and it will give you the result. See that one? And if you ask yourself whether you can maybe add a title and a description and a copyright message and a description of the parameters and so on, the answer to all these questions is yes. That's a very professional package, and this is used by professional developers of web APIs every single day. So this is just a basic scenario, but now you know at least the basic scenario and you can use the documentation to find out more. Okay? Good. And where do we get the Swagger from? Well, here. If you follow this link up here, you will get the generated Swagger. See it here? And again, we can copy this, go to editor.swagger.com, not com, IO, thank you. I'm in the wrong Chrome browser, so come on. Here it is. I can paste in the generated file, and you see, you now have it in the Swagger editor, exactly the same UI. Yep.
Can we use the internet in our files?
Pardon?
Can we use the internet in our file exams?
I don't think so. I am not the reason. If you ask me, of course you could. But I think the general policy in this school is no. I'm not sure yet. What we will make sure is that you can use certain internet sites, and I will make sure that you at least can access docs.microsoft.com. So that will definitely be accessible. Maybe we will also make editor.swagger.io accessible, but I don't think that you can use everything. But docs.microsoft.com, that's absolutely necessary. Otherwise, it wouldn't make sense. I don't think that you will have access to my slides. I don't think so. But you are allowed to create one cheat sheet, Spickzettel, and you can copy something from my slides. But we will see that. Okay, we will check that. Okay, so now what can we do with that? Take a look at here. Here's the magic. Here's the magic at home. Generate client, and now you can create a lot of different clients with a single click. Do you want to create an Android app with Java? Click on it, got an Android app. Do you want to use a Swift application for an iOS device? Click on it and you get a client. And again, if we click here on C#, we will get a C# client in the form of a zip file. You see it here. I click on it and I get a typed client with a Visual Studio solution, you see that one, and you can immediately use it. However, I personally would not recommend the code generation from here if you want to create a C# client or a TypeScript client. There is a better tool which works really nicely with NSWAG. And that's you have it here, the NSWAG Studio. You can follow the link to install it. I've already done that. You don't need to install it now. It's pretty large, I think. This is the API that you will get then. And what you can do is you can run your app. Exactly the app that we created. Go to the Swagger page. Click on the Swagger link. Copy the URL. Put it here and select C# client. Click, and then you have a lot of settings. I will not go through all the settings here because it will take us forever. Read the documentation if you need to. And at the end, you just specify the name of the file that you would like to create. Let's say, in my case, C temp, I don't know, pokey client HTL Perg.cs. Generate files. It will get the Swagger file, it will generate the C# code, and if I now, for instance, go to Visual Studio Code and open the code here, you see, this is all generated code by NSWAG. And the beauty here is that somewhere hidden inside here it is the generated Pokemon class. So if you do that, you don't have to type in the data transformation objects by hand. You can auto-generate them. And believe me, in real-world applications, you have dozens, maybe hundreds, if not thousands of these classes. And generating them by hand is very, very boring and error-prone. And imagine what's happening if the server changes. You don't want to manually do the changes in your data transformation objects. You just want to regenerate the client and everything should just work. You get the idea? That's the whole idea of this NSWAG stuff. Unfortunately, NSWAG is not capable of generating Java clients. So for your Matura, if you decide to combine server C# and client Java, you cannot use that one. It doesn't work. You have to use the editor.swagger.ui, I showed you that before, or I'm not sure if I recommend that, but it's a little bit more complicated, but it's very robust. You can think about using AutoRest. AutoRest is from Microsoft, and you see they use it internally to generate all those clients, a lot of clients. And this is the real stuff that Microsoft uses to generate all their clients for the Azure platform. Tens of thousands of developers are relying on this component. So this is very, very stable, but it's not that easy to use. Maybe if you want to give it a try, you can try it, but I think for the Matura, we will make sure that editor.swagger.com is sufficient. Or maybe you use a generator that you will learn in the Java class. Maybe you use this RESTlet stuff, right? I think this has a generator too, but you will learn that in the Java class. I will teach you how to auto-generate the Swagger. From there on, no longer my job. You know my relationship with Java. It's not that intimate. Let's put it that way. Good. Good. Now we could generate the client. What do you have to remember? Essentially, add the NuGet package, add 2 lines to configure services, add 1 line to configure, done. Very nice. Good? Good. Let me quickly show you the homework that I gave you. The classroom link is already in your Webuntis, so I don't need to give you that one. But I would like to talk a little bit about the content of the homework. It's not a lot of work, so probably you will finish it within half an hour or an hour or so. It's really not complicated, but I want you to try it, to try the HTTP client. Please take a look at the video beamer. I would like to show you some things. The idea is that you are working in a company that uses a fictitious software product called TripPin. Fortunately, there is a ready-made service on the internet which is called TripPin. It's a pretty large REST API trip like in travel trip. And this public web API knows a lot of features. So you can take a look at all users, you can take a look at details about a user, you can query for names of airports, you can query for travels and things like that, a lot of things. The only thing that is relevant for us are these 2 examples. Get a list of users, get a specific user, okay? Good. Now what is your job? You got a list of new users. I added this list of users to your homework. It's a JSON file. You see that one? It's 101 users. First thing that you have to practice, parsing JSON with the new JSON serializer. Not that complicated. Now what do you have to do? You have to go through all the users in this file, and then you have to check whether the user already exists. Let me show you how this is meant. I copy this URL, this one, put it here. Let's question whether Russell White already exists. Enter. Yes, Russell White exists. Let's see whether Rainer Stropek already exists. Nope. Rainer Stropek does not exist. The resource is not found. See that one? So for every line in this file, you have to do this HTTP request to find out whether the user already exists. If the user exists, ignore the entry in the users file. If the user does not exist, add the user. And how do you add the user? You have to send a single HTTP post where you specify the data of the user, as shown here. Get it? That's it. Nothing more. That's the whole exercise. You have to practice how to parse JSON, how to send HTTP GET requests, how to process the result, ensure status code, can remember that, and how to do an HTTP post. That's it. However, I want to give you an additional important tip. It's this one. If you want to write to the trip pin database, you have to get a so-called key. Let me show you what I mean. If you follow this link and you click on any URL, for instance this one, then the URL will change, you see that one, and a list of strings is inserted. It's a key that is specific to you. And then you can also write to these URLs. And then you have your own, let's say, copy of the database. Because otherwise, if one of you would finish the homework, the others couldn't do the homework anymore because the data is already in. You know what I mean? So therefore, if you access any API here, I want to show you that with the Russell White again. Let's query for Russell White again. Then the URL suddenly changes and you get this ID within here. Now you can delete Russell White, for instance, but you won't delete the real Russell White. You will only delete Russell White from your copy. Get it? So create such a key and then play with this key, and then you have your own unique data set. Do you understand what I mean? Approximately? Good. Good. Now, it's important for me that you do this homework. It's not relevant for next week's exam, but still it is C#. So if you do this homework, you're practicing C#. But it is important for your exam in 2 weeks. So everybody who successfully creates this application, a working application, send me a GitHub issue, will get an extra point for this homework, okay? I want everybody to try it. Give me at least your best try. Okay? Good. Any questions regarding the homework? Any questions regarding HTTP client? Any questions regarding the debugger? Good. Then we are done for today, and you can use, if you want, the last 10 minutes to maybe clone the homework repository, and then we will wrap it up for today. Thank you. See you next week.